Hello, my name is Andrew Wood, and this is the AE 1601 Glider Report. Design requirements for the glider. The general design requirements we were given are must fit within a 16 by 16 inch box viewed from the overhead. Use the materials we were given for the structure for the majority of the glider, and be able to reach at least a distance of 20 feet when thrown on level ground. Interpreting the design requirements. The design requirements we were given have several considerations for our design. The first of these is the wingspan can have a maximum wingspan of 16 inches. For a glider, the longer the wingspan, the more lift generated and the farther the glider can go. This also impacts how far we can put the tail from the main wings, farther away being more stable. The second design consideration is the material we were given. This means that this structure will be very light, but that we have a limit to the area available to act as airfoils. This total area is 72 inches squared. The third design consideration is less impactful because the goal is to go far beyond 20 feet. Initial ideas. I created 4 initial ideas for my design, and the 4 ideas are: the first was a standard glider with large wings in the front, and using the full 16 inches of length to place my horizontal and vertical stabilizers as far from the center of mass as possible, inspired by real gliders in the top picture on the right. My second idea was to do the same style of glider, but with the horizontal stabilizers in the front and the main wings and vertical stabilizers in the back, inspired by the XP55 Ascender, the middle top picture. My third idea was to make a twin boom style glider with 2 fuselages spanning the distance between the main wings and the horizontal and vertical stabilizers, inspired by the P-38 Lightning, the middle bottom picture. And my fourth idea for the glider was to have delta wings and a T-style tail with the horizontal stabilizer placed on top of the vertical stabilizers, inspired by the Gloster Javelin. Idea evaluation. Idea 1 was the highest contended, being light and a proven glider design, and the pros of this design were very high. Idea 2 had a lot of problems, including the instability generated from throwing a glider with a rearward center of mass. This would mean a high chance for the glider immediately losing control. Idea 3 had a lot of pros, including the increased roll stability because of the distance of the fuselages from the center of mass. The cons are that this is heavier than the other designs, using more of the wooden post provided. Idea 4 had the pros of having less drag because of the swept wings and the stability generated by the general design. The cons are that the design is very fragile, and after testing, the tail was likely to break off entirely. Sizing. The sizing was easy for me to decide upon because I wanted the highest surface area of lift possible to keep my main wing and horizontal stabilizers as far as possible from one another. I decided to originally go for a maximum wingspan of 16 inches, and because of my design selection, a length of 12 inches for the fuselage, plus a little more for the vertical stabilizers and additional mass placed up front. This provided maximum lift for the main wing possible, without adding additional material of another row of wing. Design selection. The design I settled with ended up being a combination of designs 1 and 3 featuring both long, straight wings and twin beam fuselage. I chose long straight wings for my wing design because they would allow me to get the greatest surface area with a maximum wingspan of 16 inches, instead of adding an angled leading edge and reducing lift. I also chose to put the wings in front because having a center of lift in the front would cause the being close to the center of mass would create less instability in flight versus having them closer. I ended up putting the horizontal stabilizers on the top of each boom unconnected at first, in front of the vertical stabilizers. The vertical stabilizers follow the design inspiration of the P-38 and extend below the fuselage. I also decided to use superglue for the adhesive so that it would have minimal impact on the flight characteristics. In the top right picture, you can see my design placed in a 16-inch square, viewed from the overhead. Initial testing. Initial testing went fairly poorly, with the tail being far heavier than expected and causing the glider to pitch up constantly. This, along with the glider breaking every other test that needed to be repaired with paper, meant the original design was insufficient. For my lift and drag coefficients, the weight was 0.52 pounds, the wing planform was 42 inches squared, and the average velocity was 16 feet per second. And those are my lift and induced drag. I was able to use the formulas provided to calculate the coefficient of lift and the coefficient of drag coefficients. Design iterations. The design iterations from the initial plans to the final design include the addition of paper to bridge the 2 horizontal stabilizers and the repair of the wings and stabilizers with paper. I also taped 5/4 to the front in front of the main wings to balance the glider and cause the center mass to shift forward. This caused the glider to no longer pitch upward when in flight. When the center of mass was more under the wings, the glider would become more stable in the pitch uh, vector. This would place the center of mass behind the quarter chord of the wing, and the added lift of the tail would also cause the tail to not drop as much. Conclusion: This project was overall very fun and enjoyable, but I think I would have gone for a more traditional style glider if I was ever to do the project again. Thank you for making this class so enjoyable.